To begin this demonstration, we're going to find and download the data. The data.gov website has an incredible amount of data to explore and use for practice. You can sort by formats, governmental organization, topics, and more. Today, we're looking for something specific, so we're going to use the search function and enter the keyword meteorites. Meteorite landings is the first returned entry, so we click this link to get to our data. Data can be downloaded in a variety of forms, depending on how you plan to process it, but in our case, we want the CSV, so we click the download link and then head into QGIS. Before opening the data, we're going to check the file to determine what column titles are, so we know how to bring it into QGIS with its spatial component. I'm using OpenOffice, a free and open-source version of Microsoft Office. If you're using Office, the process looks nearly the same using Excel. Scrolling across the columns, we see that our latitude and longitude are easily identified, so onto QGIS. We're starting with an OpenStreetMap base map, but you can choose any map you like. Once we pull in the data, you'll see that it clearly shapes the outlines of the continents, and that could be an aesthetic choice without a base map, if you like. To bring in the CSV, click on the Data Source Manager, which should be on the left side of the toolbar. If you can't find it, you can click Layer from the drop-down menus and find it as the first item. On the left side of the Data Source Manager, click Delimited Text and click the three dots to the right of the entry bar. After navigating to your data, click Open and check out the settings. The only thing we should need to change is adding the longitude for X and the latitude for Y. Click Add and Close. We need to save the CSV as a shapefile in order to edit it, so right-click on the entry and scroll down to Export and click Save Features As. Name your file and place it, then ensure the new file is in the same coordinate reference system as your base map, or whatever CRS works best for your desired outcome. Ensure Add File to Map is checked and click OK. I usually delete the CSV for simplicity, but you can also uncheck its visibility. Now, double-click on the shapefile and click on Symbology on the left side menu. I've created a meteor-like SVG file to use as an icon for our map. There is a link in the description to the SVG file hosted in GitHub if you'd like to use it as well. To add the SVG, click on Single Marker, then the drop-down menu, and select SVG Marker. Scroll down, click the three dots next to the entry bar, and navigate to the SVG and select it. Scrolling back up, I'm going to size it up some and see how it looks. Now we add the temporal element. Double-click the shapefile again, scroll down on the left side menu, and click on Temporal. Check the box to enable the function and select Single Column for Date Time from the first drop-down. Then the next drop-down we change to include first and last features. When we try to select field, we have no options, so select OK to close the Properties menu and open the Attribute table. This is an icon on the right side of the toolbar. When sorting by the year value, we see that a lot of features don't have a year associated, so we're going to delete them to clean up the data. First toggle Editing, then click on the Select by Expression button on the top of the Attribute table. Once open, we're going to open the Fields and Values tab and double-click on Year. This puts the value into the expression, and we add to this is null. After clicking Select Features, we can already see that many have been highlighted. I've also deleted the 860 feature, as it's very far before the others, and will make for a smoother animation. Scrolling through the earliest entries, we see that the records are really sparse until about the mid-1700s. I pick 1740 for the start year, and noticing that we have a record labeled in the 2100s, I decide to further hone the data. Again opening the Select by Expression and double-clicking Year from Fields and Values, we then finish the expression with greater than 1740 or a year less than 2025. Now we click Select Features, close the selection window, and again click Delete. I save my changes, and now I'm ready to convert the year in integer format to date format. Click the Field Calculator button and in Create New Field, give the new column a name. Change the data type to date and enter into the expression field 2_8 concat year -0101. Be sure to use this exact syntax, or you'll likely be met with an error. Click OK. Going back to our attribute table, we can scroll over to ensure the column is created correctly, and when all looks good, click Save and toggle the editing to off. Close the attribute table and double-click on the shapefile to open the Properties window again, and we should still be in the Temporal tab. We can now select the name of our new column, and we need to determine how long our event is. (2025 minus 1740 is 285 years, so we input that, and now we've set up the temporal function. Close the Properties window and find the Temporal Controller panel, the clock button near the top middle of the toolbar. The dates are incorrect, so clicking the Refresh button can help. If it doesn't automatically adjust to the year selected, you can manually edit it. Click the button in the Navigator panel that says Animated Temporal Navigation and press play, and we can preview our animation. I changed the frame rate to 1 frame for every 1 year, and we get a preview. I want to add a year label to be able to see what year it is as the animation progresses, so we click on the View drop-down menu and open the Decorations menu, then click Title Label. Check the box to enable, and in the entry area, type at map_start_time and adjust the font, size, and location as you'd like. We're ready to export the animation now. QGIS exports the animation as frames, so I'm saving this to a folder alone. Click the Save button on the Temporal Navigator, ensure the area, click the check that saves the label on top, and locate where you want it saved. We're now ready to turn our frames into an animation. I'm using GIMP, but this can be done in other photo and video editing software. Click the File drop-down and click Import as Layers. Navigate to your folder, select the first item, and hold Shift plus down arrow to select all the files and click Open. This takes a moment, as it processes each file. Once loaded, ensure that the earliest file is at the bottom and the latest at the top. If this isn't the case, you can click Filters Animation Optimize for GIF, and it will reprocess them. If this doesn't work, you can select Reorder Layers from the Layer menu. First, we'll crop the outside area. Highlight the area you want to keep, and hit Enter to remove the background. Ensure the option in the panel on the left that says This layer only is unchecked. Click on the Filter drop-down, open the Animation menu, and select Playback. We can now see if the animation is running correctly. After approving the animation, click File and Export As. Rename the file with a .gif extension and click Export. In this final pop-up window, click as Animation, then Export. We can now go to the file location and play our animation into eternity. Thank you for watching, and I hope this tutorial is helpful and gives you ideas for animated maps you could make.